Hello dear students, good morning and welcome back to the chemistry class. In the previous class we have discussed about the factors affecting the rate of reactions. Now in today's session I am going to teach you about the next concept, that is concentration dependent rate. Take the next heading, concentration dependent rate. Concentration dependent rate, that is dependence of concentration on the rate of reaction. As we know that if concentration of reactant increases, then rate of a reaction also increases, that you know about it. And even in graphical representation also you know that. I'm writing the simple graphical representations, rate versus time. So this is concentration versus time. So for this curve represent product and the second curve represent reactant. So this is product and this represent reactant. Product and reactant. Its concentration decreases and its concentration increases. Now, from this concept, one thing clear that rate of a reaction is directly proportional to concentration of reactant. Am I right? Rate of a reaction, the rate, velocity, speed is directly proportional to concentration of the reactant. And here the relation between the rate and the concentration term is given by Ambajogai and Maximilian Goldberg. The relation between concentration of the reactants and a rate of a reaction is given by Maximilian Goldberg and Ambajogai. They gave the quantitative relationship between rate and concentration terms. This relation is known as law of mass action. This relation is known as law of mass action. Now let us discuss about the law of mass action. Law of mass action. So this law of mass action states that, or it gives a quantitative relationship between the rate of a reaction with the concentration term. So here let us consider a hypothetical reaction where the reactant which gives rise to product. Simple reactions I have considered. So in this case, here according to the law of mass action, the rate of a reaction is directly proportional to concentration of reactant for this hypothetical reaction. If I am considering another general reaction, A plus B, which gives rise to product. In this case, according to the law of mass action, we can write the rate expression. Rate is directly proportional to concentration of reactant. A and B दो है यहाँ पर. So product of concentration of reactant. Product of concentration of reactant. So if you are considering another reactions, for example, A plus 2B, which gives rise to the product, in this case, the rate is directly proportional to concentration of A into concentration of B to the power 2. Here where this 2 is, it's a stoichiometric coefficient. Now in all the case, if we remove the proportionality symbol, then we are going to express rate is equals to some constant K into concentration of reactants. It is for this. In all the case, this proportionality symbol can be replaced by some constant K. K is known as a constant of proportionality. It is called as velocity constant or a rate constant. This is known as rate constant, or simply we can call it velocity constant, rate constant or velocity constant. This is about rate constant and velocity constant. Is it clear? So let us write the rate expression for a simple and generalized equations where the stoichiometric coefficients are different. Let us consider one such reactions. A moles of A which reacts with B moles of B. This in terms gives rise to the product C moles of C and D moles of D. I am generally writing it as a product. So for this, if you are writing the rate expression, then rate is directly proportional to molar concentration of reactants, where as you know that the square bracket which indicates this indicates molar concentration, and its unit is moles per liter. Moles per liter is the unit. SI unit moles per dm cube. SI unit is moles per dm cube. And it is also known as, this term is also known as active mass. इसको active mass भी बोल सकते हैं हम. क्या है? Active mass. It is also known as active mass or molar concentration, and its unit is moles per liter. So here A and B are the stoichiometric coefficient. So therefore these concentration terms are raised to the some powers which may or may not be equals to stoichiometric coefficient. So therefore I am writing in place of A and B as X and Y, where X may or may not be equals to A and this Y may or may not be equals to the B. Experimentally determine rate. So about this once again we are going to deal. So if I remove this proportionality symbol, I can write rate is equals to some constant K into concentration of A to the power X and concentration of B to the power Y, where this Y, X and Y may or may not equals to X and Y or may or may not equals to A and B respectively. Sometimes this X may be equals to A or which may not be equals to A, something may be different. तो ये हुआ आपका law of mass action. And during this law of mass action, the constant, proportionality constant is known as rate constant. Please note this, where K is constant known as proportionality constant, or it is also known as rate constant, or simply we can call it velocity constant. And here you can write the unit and characteristics of this rate constant. Please note the characteristics of rate constant. Characteristics of velocity constant. Please note the heading, characteristics of velocity constant. ये जो rate constant है इसका characteristic properties क्या है? What are the characteristics of this velocity constant? Note this one. So in the topic equilibrium we have studied what are the characteristic properties of equilibrium constant. Physical and chemical equilibrium में study किया है. Exactly those points we just recall now. क्या था वहां पर? Equilibrium constant is only temperature dependent. That means it varies with the temperature. Concentration के ऊपर dependent नहीं था. Larger the value of equilibrium constant, greater the extent of reaction, and vice versa. And For a given reaction, equilibrium constant value is fixed. Exactly in the same way, larger the value of K indicates faster the reaction. Larger the value of K, this indicates faster is the reaction. Faster is the reaction. Fast reaction. Simply we can write fast reaction. If small value of K indicates smaller the value of K, this indicates slow reaction. So the magnitude of this K value indicates whether the reaction is fast or slow. Rate constant, velocity constant का value अगर ज़्यादा है, that indicates the reaction is fast reaction. If its value is slow its value is less, that indicates it is slow reaction. This is first characteristic property. Next, for a given reaction, K value is constant. For a given reaction, K value is fixed. And this K value is independent on initial concentration. Concentration के ऊपर dependent नहीं है, whereas this K depends on temperature. Its value depends on temperature. K value depends on temperature, and units of K depends on order of reaction. This concept we are going to discuss later. Order of reaction. This concept depends upon order of reaction के ऊपर dependent. So these are about some characteristic properties of equilibrium constant. Characteristic properties. Now let us check some of the unit of rate constant. What is the unit of rate constant and how to remember? Unit of rate constant. Unit of rate constant. So now let us consider one reaction, general reaction देखिए for nth order, any order. So here I am considering if for an hypothetical reaction A gives rise to product. So in this case, rate is equals to K into concentration of A to the power n, where n may be 1, which may or may not be equals to stoichiometric coefficient. So now this is the answer. Rate can be expressed as dx by dt. Am I right? Dx by dt, that is equals to K into concentration of reactant to the power n. Dx, what it indicates? Infinitesimally small change in the concentration. That means change in concentration. अब concentration का unit क्या है? Concentration unit is moles per liter divided by change in time, that is second, that is equals to K into, again this is also concentration है ये भी. So concentration बोले तो इसका units क्या रहता है? Moles per liter to the power n. So therefore we can write K is equals to ये क्या है? Moles per liter per second. Moles per liter per second divided by this term, divided by moles per liter. Now ये दोनों terms same है. This both the terms are same. This is to the power n है. अगर same रहा तो cancel हो जाएगा. So therefore ये n है इसका values. Therefore the general unit is moles per liter to the power, ये 1 है, ये ऊपर आया तो माइनस हुआ, 1 minus n per second. Please note this unit of rate constant. Important है. What is the unit of rate constant for nth order reaction? ये order of reaction आगे हम डिस्कस करते हैं आपको. फर्स्ट ऑर्डर, सेकेंड ऑर्डर, जीरो ऑर्डर. अगर ये फर्स्ट ऑर्डर है 1 - 1 0, फर्स्ट ऑर्डर को ओनली फर्स्ट है. दिस इज इन सोल्यूशन. अगर वो गैस में रहा तो K इज इक्वल टू यूनिट क्या है? एटमॉस्फेयर. यहाँ पर एटमॉस्फेयर आर बार टू द पावर 1 माइनस n per second is the unit in case of gaseous phase reaction. Please note the general reaction, बहुत important है. Unit of K, velocity constant in solution phase and in gaseous phase. In gas phase ये solution phase में इसका unit है and ये gas phase में इसका unit है. Please note the unit of rate constant. अब देखिए यहाँ पर आपको दो पॉइंट आया है. One is rate of reaction and second one is rate constant. Can you find the difference between rate of reaction and rate constant? Rate of a reaction, rate of reaction, ये देखिए rate of reaction यूनिट क्या है? फिक्स्ड है, मोल्स पर लीटर पर सेकेंड. लेकिन यूनिट ऑफ रेट कांस्टेंट क्या है? वो वेरिएबल है. यूनिट ऑफ, टेक द नेक्स्ट हेडिंग, डिफरेंस बिटवीन रेट कांस्टेंट एंड रेट ऑफ रिएक्शन. डिफरेंस बिटवीन, differences between rate of reaction, difference between rate of reaction and rate constant and rate constant. So please note two columns. One is rate of reaction, and second one is rate constant. Second one is rate constant. Rate of reaction, first point यहाँ पर definition लिखिए इसका. First point is definition. Same both के केस में first point is definition. What is the definition of rate of reaction? Change in concentration of reactant or product per unit time is the definition. ये point है. Rate constant का definition क्या है? देखिए, in all the rate expressions you can find rate constant का definition होना है तो इसका values 1 होना चाहिए. The rate of a reaction for 1 molar concentration of reactant. If the concentration of reactant is 1, then the rate of a reaction is known as a rate constant. That means इसका definition क्या है? Rate constant is defined as it is the rate of reaction for unit concentration of reactant. For unit concentration, क्योंकि इसका values 1 हुआ तो दोनों सेम हो जाएगा. यहाँ पर भी देखिए, if A is equal to 1, B is equal to 1, 1 to the power anything that is equals to 1, 1 into 1, 1, so that is equals to K is equals to rate of reaction. So first point definition हो गया. Here it is, ये क्या है? Concentration dependent है ये, concentration dependent, whereas the second point concentration के ऊपर dependent नहीं है, concentration independent है. And rate of reaction and rate constant both are dependent on temperature, both depends upon the temperature. Its unit is moles per liter per second. Fixed रहता है इसका unit, but its unit is moles per liter to the power 1 minus n and per second. So it depends upon n values. N may be 0, 1, 2, 3 or even fractional order also. That n may be different values. These are some of the differences between rate of reaction and rate constant. Please note this. Okay, dear students, in this class we have discussed about a simple concept, concentration dependent rate of reaction, where we have studied the law of mass action. According to Maximilian Goldberg and Peter Wage, they given the quantitative relationship between the rate of a reaction with the concentration terms, and according to that, the law of mass action states that rate is directly proportional to the concentration of reactants. If it is more, product of concentration of reactants. Am I right? So according to that, if we remove the proportionality constant, we are getting the rate constant. A proportionality constant known as rate constant or velocity constant, uska characteristics and difference between rate constant and rate of reactions we have studied. In the next class, we discuss about rate law expression and order of reaction. Rate law expression and order of reaction. Please note this concept. Thank you.